There's a question that has quietly haunted computing for 70 years. Not how to make computers faster, not how to make them smaller. Something far simpler and far harder. Why can't you just talk to a computer the way you'd talk to a person? You can ask a colleague, "Get that stuff I received last week from the guy in Canada and send it to the fellow I met in Geneva last year, together with our Apple catalog," and they'll do it. Ask a computer, and nothing happens. 70 years, trillions spent, and that sentence still cannot be executed by any machine on Earth. This briefing is the story of the man who found out why, and what he built when he did. What you're about to hear is a guided walk through the confidential technical briefing on ExoTech, the work of its inventor, Peter Warren. It is confidential for a reason. What it contains is not an improvement to software as we know it. It's a different answer to the question entirely. Once you've seen what Peter saw, the whole industry looks like it's facing the wrong way. Let's begin with what ExoTech is actually for. The objective, stated in one line: a computer that can be comprehensively controlled with normal, everyday language, as if it were a person. Not commanded through menus, not programmed, spoken to. The first model Peter used was the boss and the secretary. Whatever a capable assistant could do for you, the computer should do too, told in exactly the same words. Notice how that feels for a moment. No manuals, no training courses, no hunting for the file you know is in there somewhere. Just saying what you want and having it done. And behind that objective sits a larger purpose. The goal of the company is this: to get the full potential of computing into the hands of the world population in a socially responsible manner. Today, most of the people on this planet use a computer for little more than email and browsing, if they use one at all. Not because they lack intelligence, because the machines demand that humans learn to think like software. ExoTech reverses that. It teaches software to think like humans. Two definitions, so we're precise. ExoTech, a new species of computing software that works on the same principle humans use to think, and is capable of making a computer do much of what humans can do. ExoBrain, computer software built according to the teachings of ExoTech. One thing to settle right now, because it's the first question everyone asks. This is not artificial intelligence. No guessing, no statistical prediction, no black box. What you'll hear described is a set of discovered laws about how humans handle language, data, and activity, engineered directly into software. AI predicts. ExoBrain understands the specification and executes it. Hold on to that distinction. Peter divided the problem into two parts. Part 1. Turning language into an order a computer could execute, if it had the software to execute it. Part 2, the far harder one, we'll come to. He describes the early research as being like a tank full of eels. You have to find the right one and pull on it before you can get anywhere. Here's the first eel, in other words, the first of those tangled subproblems we're going to pull out and deal with. A language order consists of words, and most words have more than one meaning. Take fax. Fax the machine, fax the piece of paper, fax the activity of faxing. So a simple three-word order, where each word carries three meanings, actually communicates 3 by 3 by 3, 27 possible orders. 27 things you might have meant. And computers are built of transistors. Transistors do on and off. They do not do, it's one of these 27, go figure. So the first step towards a solution. Give each word and each meaning of each word an unambiguous identifier so it can be individually accessed and individually handled. Numbers are perfect for this. Number 27 has no intention of ever being number 34. If every meaning has its own number, then an order like fax this to Joe can be resolved to something like 4, 8, 10. A sequence that cannot possibly be confused with anything else. Unambiguous. and therefore, in theory, computer executable. But that only works if you can tell which meaning is in use. And here's the encouraging part. You already know it's possible because you are doing it right now, effortlessly, with every sentence of this narration. How? Peter found the answer with a deceptively simple experiment. Suppose someone says, "the dogs," and that's all they say. How many dogs? One? More than one? You cannot tell. Two meanings of that letter S are in play at once. Now add one word, the dog's collar. Instantly, the S means the next thing belongs to the previous thing. One dog, one collar. Different word instead, the dog's running. Now the S means more than one dog. The word that arrives next selects the meaning. Nothing mystical. Something is choosing, automatically, invisibly, every time. What's choosing is rules. Rule 1. If the name of a type of thing has an S on the end and is followed by another name of a type of thing, the S means the next thing belongs to the previous one. Rule 2. If it's followed by an action, the S means more than one. You had these rules hammered into you at your mother's knee. No, Johnny, it's one dog, use is. And yet there is no book on this planet that contains them. Not one. Peter tested this against reality. He took a page of Newsweek and worked through it word by word and found he could always construct a rule that detected the correct meaning in use. Every word, every time. So language could be processed into unambiguous, numbered, theoretically executable orders. Problem 1, the one everyone assumed was the whole problem, took 6 months. And at that point, you reach for the Nobel Prize application form, only to realize you've achieved precisely nothing. Because now you're in the position of the boss who says, "Jill, do me the balance sheet for General Motors for last year, will you?" And Jill knows exactly what a balance sheet looks like and hasn't a clue how to make one. You can hand a computer a perfectly unambiguous order, 24, 37, 98, and there is nothing in today's computers capable of processing it. What are you going to give it to? Excel? Word? There's nothing there to receive it. The language problem took 6 months. This one, the data problem, took 2.5 years. And it's where everything you think you know about software quietly comes apart. The solution began with looking at orders in a completely different way. Every order splits into 2 parts, an action and a specification on which to act. Print, my emails. Email, the thing Joe sent me yesterday. Find, the banana catalog. Display it, on my desktop. Now, there's no difficulty on the action side. You could build a little program tomorrow that hears print and pushes the print button. That's essentially what today's voice assistants are, language button pushers. So if the problem isn't on the left, with the actions, there is only one place it can be hiding, on the right, in the specifications, as we saw on the previous slide. Here's the thing. Software already has a completely unambiguous specification system. The exact date and time saved, the exact size, the exact file name, the full path, the position in the directory. Every installed program you've ever used runs on combinations of these, and runs on them very successfully. So let's give you, the human, a little eligibility exam on that system. Think of a specific file you worked on a couple of months ago, a document, a spreadsheet. Got one? Question 1. The exact date and time you saved it, to within 1/10 of a second. Question 2. The exact size, to 1/10 of a kilobyte. Question 3. The exact file name, capitals, spaces, everything correct. You might get close on that one, but believe me, not exactly right. Last question. The full path, every slash, every folder, every character. How did that feel? A little humbling? Good. Now you know exactly how the computer feels when you say, "The thing Joe sent me yesterday." That feeling has a name: a specification mismatch. Humans cannot use software's specification system, and software cannot use the human one. And there is only one possible way out. Since people can't learn the software system, you just proved that, the only option is to discover what the human specification system is and get computers to use that. Without it, a truly language-controlled computer, not a chatbot, not a voice gadget, not a jukebox of preset commands, will never exist. Not now, not ever. And here's the astonishing part. There are 8 billion people on this planet, every one of them using this system fluently every waking hour, and nobody knows what it is. Search for the human specification system. You'll find nothing. Not a paper, not a theory, not even speculation. Humanity's most used system, and no one had ever mapped it. So Peter mapped it. Start with one word. Suppose you say my, and that's all you say. You have a phone? Is it my phone? And its 1,000 components, each of those my too? Your car and its 100,000 parts? The things you owned 20 years ago and the things you'll own 10 years from now. And what about the ancient Romans and their spears? One little word and you've specified trillions upon trillions of things, from which we learn something remarkable. Every single meaning in language specifies not one thing, but a huge type of things. Say tree, and you've specified every tree that ever was or ever will be. Human specification is a type-based system. And notice what else happened. The instant you said my, everything in the universe that is not yours was eliminated from the conversation. One word and most of everything gone. Now put words together and watch what happens. My friends. You're no longer talking about everything that's yours or everyone's friends, only where the two overlap. Add clients, smaller still. Add New York, and from the entire universe, beginning to end of time, 4 words have brought you down to one tiny, precise intersection. And you could keep going. My New York client friends who came to my Christmas party last year. This is the co-reducing concept principle of human specification. Each meaning is a type. Each added meaning reduces the field to the overlap. And there are no exceptions. None. This is how humans specify things, and there is no other way they do it. Feel the ground shift slightly? That's the sensation of seeing the machinery behind something you've done unconsciously your whole life. There's a second law hiding in plain sight, and you can prove it to yourself. Think of any order you might give someone, anything at all. Now imagine time has passed, and try to ask whether it was done, without using any of the words from the original order. Go on, try. You can't, which tells you something enormous. Orders like, the thing I printed yesterday and sent to Joe, cannot be found, checked, or reused if the original order was never recorded. And then it hits you. In today's computing, none of your orders are recorded. Excel doesn't remember that you printed that sheet on printer 2. Word has no idea it was ever sent to Bill. The computer has a phenomenal memory for content. Give it the Library of Congress and it will hand it back verbatim in 400 years, and almost no memory of execution, of what was done. The human is precisely the opposite. Hazy on content, remarkably good on execution. So one of ExoTech's laws, there are around 30 of them, each non-negotiable, is the order principle. The computer must remember what it does, at least as well as a human does. It's one of some 260 showstoppers Peter catalogued, things which, if missing, stop the show entirely. With the principles in hand, Peter did what any careful researcher does. He gathered a pile of real orders. Make an appointment with Joe of IBM at the Hilton on Wednesday. Pay the rent on Monday. Print the spreadsheet for Bill. Invite Sally to the dance. And looked for structure. And structure appeared, almost immediately. Every meaning in every order classified naturally under matter, action, space, and time, plus life and administration. This is no accident. Language exists to describe the physical universe and the things we imagine within it. And the physical universe is built of exactly these: matter, action, space, and time, the same in Fiji as in New York. So the underlying meanings must be the same in every language on Earth. Life covers the values that only exist because people exist: good, bad, quick, slow, even a color like blue. Picture a planet with no people on it. The wavelength remains, blue does not. Each category divides into classes, and here is the finding that stunned him. About 350 data classes are all you need for office use. 350 compartments, and everything fits. And those meaning-detecting rules from the start? They depend on these categories. Remember the eels we were talking about earlier? It turns out they were all connected. So why can't today's software simply adopt all this? Because of how it's built. Peter has a name for it, a little rude, he grants: lumpware. Software comes in lumps. A code lump, 3 gigabytes of a program like Word. Data lumps, documents. Now give the order: computer, turn the first word in the third paragraph bold. That order must somehow travel into gigabytes of code, locate the bold routine among thousands, then persuade it to cycle over to the right data lump, find the third paragraph, find the first word, and act. Multiply a couple of thousand actions by the trillions of places they might need to occur, and you can see, it is impossibly complex. It only works at all because a programmer hardwired each path in advance, something no human would ever have to do. Now, how to fix that? The same way the language problem was solved. Words had been broken into separate meanings, each handled individually. So Peter broke software into its separate parts: prompts, labels, conditions, interface, and the small pieces of code that actually change data, each handled individually. The same key opened both locks. Now, theory is lovely. Proof is better. Peter handed these principles to one of those genius boy programmers and asked him to make them run. The result was called Jill, a proof of concept assistant, and Jill worked. Tell Jill, send an email to Mr. Charlie Brown, and she asks only for what she doesn't already know, sends it, done. Then say something no normal program can process, send that to him again. She works out what that is and who him is and sends it. Then say, send that to him by fax. She does that. She accesses the fax ability and sends the text by fax this time. No cutting, no pasting, no learning a second program. Ask her to show me emails to Brown when she knows a Charlie Brown and a Brown Charlie, and she does what a person would do. She asks which one you meant. Tell her, speak French, and she switches and takes her orders in French too. And when she was given an order she'd never seen, add an expense. She said something no software says: please wait while I learn. The order traveled up to Mother Exobrain, the capability came back down, and it ran. Wherever the code is, wherever the data is, the Exobrain fetches it, without bothering you with the bits and pieces. Now the numbers, because they deserve a moment. All of that, email, fax, find, count, browse, multi-user, multi-language, learning on the fly, was done with 88 pieces of code, totaling 315 kilobytes, a third of a megabyte, built from scratch in 3 weeks. A new language takes 30 minutes to add. 3 gigabytes of Word can't do what a third of a megabyte of Jill did. That's not an optimization. That's a different species. Step back and notice what you just saw, because each piece demolishes a belief we've all been trained into. A conversational interface anybody on Earth can use, Peter's team took it into a cafe in Paris and watched workmen who had never sent an email in their lives send one, unprompted and untaught. Data-driven, not software-driven. Today, all software works backwards. You must choose the program before you can touch the data. Imagine humans working that way. Can you give me Bill's address? Whoa, tell me what software to use first. Absurd. With a human, the data decides the tool. Hand him a shopping list, he reaches for a pencil. Hand him a can of paint, he reaches for a brush. Jill worked the human way round. You only ever told her anything once. You never told her to save, she simply remembered, the way a friend remembers an address. You never navigated to find anything, you just asked. Every one of those is something you've silently accepted computers cannot do. They can. It simply required starting from the right principles. Which brings us to the discovery that reframes everything, the one that, by Peter's own account, amazed even him. There are not one, but two completely different types of machines in the world. The first type is everywhere, and every one of them is comparatively weak. Peter calls them one-to-many machines. One of something used with many of something else, in a way that is intrinsically hierarchical and intrinsically limited. One CD player, many CDs. Feed it a vinyl record and it won't thank you. Feed it a pint of milk and the relationship is over. One lamp, many places lit. One watch hand, many seconds ticked. Each does the single thing it was designed for, superbly, and is useless at everything else. Now the uncomfortable part. Every single piece of software in the world today is a one-to-many machine. One Word, many documents. One Excel, many spreadsheets. One video editor, many videos. No exceptions have ever been found. At the opposite pole lives a second type, very rare and almost infinitely more powerful. Any-to-any machines. Machines in which any component can be used with any other component in a way that is not hierarchical and is intrinsically unlimited. The humble Lego brick. Any brick clicks onto any brick, and with enough plastic you can model anything in the physical universe. One plain little brick built the world's biggest toy company, many say the world's strongest brand. Genetic code. Just 4 letters, A, C, G, and T. Any with any, and they write you, me, and the plant outside the window. If biology isn't your world, don't worry. It just means that every living thing is built from a tiny set of 4 chemical building blocks, and it's the order you string them in that spells out the whole recipe for life. Water. Any molecule with any molecule, filling anything from a thimble to the Pacific. And notice, power rises with the number of components. Lego has 1, binary 2, genetics 4. Now, human data handling and human activity handling. The 2 most powerful systems on Earth. Both are any-to-any machines with unlimited components, because however many meanings or actions exist, you can always invent another. Every sentence you've ever spoken is a chain of relationships that never existed before you made it. 99.9% of everything you do with data is dynamic, made on the fly. And there's a level above even this. When 2 or more any-to-any machines interact harmoniously, they form an any-to-any system, and the whole becomes greater than the sum of its parts. Only 3 have ever been identified in the universe. Hurricanes, air, and water, both any-to-any machines, interacting. Each one releases the power of between 2 and 100 hydrogen bombs. Computer hardware, binary code, pixels, transistors, interacting. It computes virtually anything. And the human being, the data machine, and the activity machine harmoniously interacting, relating any data to any data and to activity, unlimited. That is the company you keep every time you think. Now, at last, the why for 70 years of frustration can be said in one sentence. Software technologists have been attempting to satisfy humans, each of us a tremendously powerful, unlimited any-to-any system handling everything dynamically, using an endless supply of weak, intrinsically limited one-to-many machines, each handling one fixed type of data in one fixed way. It isn't a matter of trying harder, it is structurally impossible. And this wrong-headed approach, even as it generates billions in revenue when it ought to generate trillions, spins off an unending river of unnecessary problems and whole industries to solve them. Security, databases, connectivity, servers, data mining, training, search, the programming industry itself. Even the AI industry, layer upon layer, compensating for a foundation that faces the wrong way. Once you see it, you feel two things at once: frustration at 70 years of pushing on a door marked pull, and a strange calm, because a problem correctly diagnosed is a problem that can be solved. And history tells us exactly what happens when an any-to-any machine enters a territory ruled by one-to-many machines. Picture the world's ports during the last World War. Cranes swinging pallets, one load at a time, into ships' holds. In 1956, a man named McLean introduced the shipping container, an any-to-any machine. Any container stacks with any container without limit. Look at any port today. Containers to the horizon. The old ships, cranes, and docks gone within a very few years. Or the slide rule and the mechanical calculator swept off every desk on the planet by transistor computing. No fire sale, no farewell tour, museum pieces. ExoBrain is an any-to-any system entering territory ruled by one-to-many software machines. What do you think will happen? Because that is precisely what has been built. ExoTech is the first ever purpose-designed any-to-any system, designed from first principles and a clean sheet of paper to emulate human data and activity handling, not to imitate its results, to work the way it works, which makes ExoBrain number 4 in the most exclusive club in the universe: hurricanes, computer hardware, human beings, and exobrains. And consider what's new here. The exobrain and the human are the first two any-to-any systems ever to work together, side by side, on the same basis. Two unlimited systems harmoniously interacting. That should produce some very interesting outcomes. This is not a promise on a whiteboard. The briefing closes with a live demonstration of ExoBrain 2, running today. Everything in it is made by pointing and clicking, no programming. Desktops work like rooms. A kitchen holds everything for cooking. An accounting room, everything for accounts. 14 or 15 administrative staff who could not program were given a plain default desktop and a week. Peter came back to find Groucho Marx, Einstein, a purchase order, and a working game. No two exobrains were the same anymore. The team took those laptops into shopping malls and put 585 people of every age and background in front of them, with no instructions at all, and surveyed what happened. People simply used it. Every exobrain is encrypted at all times, even while running, with military-grade security, communicating through key pair encryption. And because it is any-to-any, anything can travel encrypted. A note, a purchase order, a desktop, a game of tic-tac-toe played across two machines. A purchase order translated into French, recolored, sent to Paris ready for use, a few clicks, done by a user, not a programmer. You only have to tell it once. It remembers what it did. It finds things the way you specify them. It is, in the truest sense, computing the human way. Let's return briefly to the belief we set down at the start, because by now you can see it clearly. This is not AI. It is not a smarter chatbot, not a prediction engine, not this year's model of last year's idea. AI is a one-to-many industries answer to a problem it cannot see. ExoTech is the discovery of the laws underneath, the human specification system, the order principle, the data categories, the any-to-any architecture, and software built on them from a clean sheet. Upgrades compete on speed, discoveries change what's possible, and you have just walked through a discovery, which is the whole point, and the difference in 4 words. AI guesses, ExoBrain knows. So here is where you stand. You now know something very few people on this planet know. why computing has disappointed us for 70 years, and what it looks like when it finally doesn't. You've seen the theory, the laws, the proof, and the working system. And you've felt, perhaps, that quiet click of recognition, the sense of having arrived early to something significant. Some people watch a briefing like this and file it away. A few recognize the container ship while everyone else is still admiring the cranes. The only thing left to decide is whether you're one of them. So let's have that conversation right now about where you fit and what your options at ExoTech could look like.